Hello Bobcats. So today we're going to talk about sigma and pi bonds, which are how single, double, and triple bonds are formed. So in single bonds will have one sigma bond, and we'll talk about what a sigma bond is in just a minute. So by the way, the symbol right here, sigma, is this symbol that I'm drawing right there. Okay, now double bonds will consist of one sigma and one pi bond. And in triple bonds, we'll have one sigma bond in it and two pi bonds. Okay, so now we need to discuss how these bonds are formed. What do we mean by sigma and pi bonds? Okay, so sigma bonds occur in overlap of s orbitals or s and p orbitals or hybridized orbitals. So we can have two s orbitals overlap. So that's an s and an s, and this overlap right there, that overlap is a sigma bond. Or we can have a s orbital and a p orbital. And this overlap right here, I'm not doing a very good job at getting them overlapped. Let's just say that there's an overlap there. So we have an s and a p orbital. And this overlap right there is a sigma bond between those two. We can also have an s orbital and a sp3 orbital overlap. Or so this would be the s orbital, and this would be the sp3 orbital, and this overlap is also a sigma bond. Or we can have two hybridized orbitals. Let's see if I can draw two hybridized orbitals here. So there's a sp, and then here's an sp3. So there's those two, and they're overlapping here. And so that overlap between this sp3 and this sp3 is a sigma bond. So sigma bonds can occur overlap between s orbitals, s and p orbitals, s and hybridized orbitals, and two hybridized orbitals. Now pi bonds occur when there's an overlap between p orbitals. And so you'll have a p orbital here and a p orbital here, and it's hard to draw them overlapping, so what we do is we kind of show that these parts are overlapping. And so this would be an overlap of p orbitals. They're just p orbitals. And this overlap, top and bottom, this doesn't mean, this is not two bonds. It's a single bond, but it's overlapped on top and bottom of the p orbital. You can think of this as like an orbital and an anti-orbital, and they have to lap top and bottom. So this is really not two bonds. It's a single bond with overlap on two top and bottom. And we say that the p orbitals overlapping on top and bottom to form the single pi bond. So this is two orbitals, p orbitals overlapping on top and bottom to form a single pi bond. Okay. So let's take a closer look at single bonds. And so when we take a closer look at the single bonds, we have, let's just look at methane. So we're going to use carbon right now for most of this. So if I take CH4, and we know CH4 has 1, 2, 3, 4 single bonds. And so what we get is we take this carbon that has this 1, 2, 3, 4. So that's a 2s and a 2p. It hybridizes to make 1, 2, 3, 4 sp3 hybridized orbitals. And so we can now make 4 bonds. And remember that hybridized orbital, so we have, in this case, an s, 1s plus 3 p orbitals going to 4 of these hybridized orbitals, sp3 hybridized orbitals. So that's an s, a p, and an sp3. So how does that look? I'm going to do the best I can to draw this. And so we get is, if I have my carbon right here, this is carbon, and remember this carbon has 4 sp3 hybridized. So what we're looking at is it's got this sp3 hybridized out here. Now the little part is in the carbon itself as I draw it. Then we're going to have an sp3 hybridized orbital here, an sp3 hybridized orbital here, and an sp3 hybridized orbital here. Okay, so these are all sp3 hybridized. And in each hydrogen of this is just an s orbital. Remember, hydrogen only has s orbitals. So I've got an s orbital here, an s orbital here, an s orbital here, and an s orbital here. And so there's my sigma bonds between my s and hybridized orbitals like we have up here. So each of these is a sigma bond. So that's a sigma, 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 and a sigma bond. And so you can see, in this case, carbon is sp3 hybridized. And carbon has 4 single bonds, and each single bond is a sigma bond, so carbon has 4 sigma bonds also in this case. So it's sp3 hybridized with 4 single bonds and 4 sigma bonds. So now let's look at I'm just showing here what was chosen to be hybridized. Now let's look at carbon, the double bond. Okay, so that's a single bond. Now let's take a closer look at double bonds. And what we have with our double bonds is, let's look at ethene. So C2H4. And the way that is we have a carbon, double bonded to a carbon, single bond hydrogen, single bond hydrogen, hydrogen, hydrogen. So we have to come up with a way to have 2 single bonds and a double bond for this carbon. And since they're both the same, we're just going to look at one carbon. And I'll write that we'll look at this first carbon here. Now, in this case, what we're doing is carbon is taking this 2s and these 2p orbitals, and it's hybridizing them. So it's taking those, and it's just going to take the s and 2 of the p orbitals here and hybridize them. And so we've got 1, 2, 3, and then the p up here. So we have 3 sp2 orbitals, and then we have a p orbital. And there's going to be 1, 2, 3, 4. So we can still make 4 bonds, but this p orbital is going to make part of the double bond. So when they hybridize, again, it looks like this. We have 1 s orbital plus 2 of the p orbitals, and we get 3 of the hybridized orbitals, like this, which are sp2, because we took 1 and 2 to make sp2, and then we're going to have a p orbital, 1 p orbital to bond with. So now let's look how that is going to, what is that going to look like? And so again, remember, I'm going to do the best I can to draw this. I'm not a very good artist, but I will do what I can. So what we have is this. We have a carbon, and this carbon is going to have an sp2 hybridized. There's a little dot below there, and it's going to have an sp2 hybridized out this direction and an sp2 hybridized out this direction. So there's that. And then it also is going to have a p orbital that is going this way. So that's a p orbital. So we have the p orbital here, and then we have sp2, sp2, and an sp2. We also have a carbon over here that has an sp2 hybridized, an sp2 hybridized out in this direction, and sp2 hybridized out in this direction. And we have the p orbital like this. Okay, so there's the p orbital. And in this case, this is overlapping to make a single pi bond. And then this overlap right here is a sigma bond. So my double bond includes a pi and a sigma bond. And then of course we have our hydrogen spheres, s orbitals, s orbital, s orbital where they all overlap, and an s orbital here with an overlap. So we have a sigma, 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 and a sigma. So if I look at each, just look at one carbon. We're just going to pick one carbon and look at one single carbon. And in this case, we know that the carbon, because they're both the same, I can look at them. Carbon is sp2 hybridized. The carbon has 2 single and 1 double, 2 single bonds, and 1 double bond. And then the carbon, in this case, has, and we're just looking at one carbon, so it's 1, 2, 3 sigmas. So it's 3 sigma bonds and 1 pi bond. Okay, so sp2, there's going to be, think about it, 1, 2, 3, 1, 2, 3, so it's got 2 single, 1 double, 1, 2, 3, and then 3 sigmas and 1 pi, making those 2 singles and 1 double. So that's how a double bond is formed. And now the last one is a closer look at the triple bond. Okay, so a triple bond will look like this. So closer look at triple. triple bonds. Okay, and so with the triple bond, we're going to look at ethyne, so C2H2, which is going to look like this. We're going to have a carbon triple bonded to a carbon, single bond hydrogen, single bond hydrogen. Now, if you'll notice, each carbon still has 4 bonds. 1, 2, 3, 4. Sigma, 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 and pi. So I forgot to put that up here. You can think of this as this is the pi bond of that double bond, and then the other one is the sigma bond of that double bond. So the double is made up of a sigma and pi. Now in this case, we're going to have a pi bond here and a pi bond there, so that's a pi and that's a pi bond, and then the sigma bond here. Okay, now how does this happen? So we have our carbon with its orbital diagram of 2s, 2p with 1, 2, 3, 4 electrons. It will hybridize, so it takes these two and hybridizes them, moves the electron over to the p, and so we get 1, 2 sp hybridized orbitals and then 1, 2 p orbitals. So in this case, we have 1 s orbital, and then we're going to add to that just the 1 p orbital, and so when it hybridizes, we get 2 of the hybridized sp orbitals, and then we still have 2 of the p orbitals to work with. So there's a p, so we have 2 of the p orbitals to work with. So I'm going to do the best I can again to draw what's happening in a triple bond for carbon. So we have a carbon. In this case, we only have 2 of these, so I'm going to have a hybridization going out this way. So there's my hybridized orbital, and then my other hybridized orbital goes out this way. Okay, so and then I want to have a p orbital going up and down like this, and then I'm going to have a p orbital going in this direction, and I will kind of color in this one so you can see it's different. So I have 2 p orbitals, and then this was the sp hybridized, and then I have the other carbon that has the sp hybridized. So there's my other carbon, sp hybridized. So sp and sp, and again we have a p orbital going up and down, and one going in and out of the plane. So here's the other p orbital, and let's look at the overlap. So we have an overlap here, so that's a sigma bond. We have the hydrogens with their s orbitals. There's an overlap there, so that's a sigma bond. An s over here, which overlaps, that gives me a sigma bond there. And then we're going to have an overlap between this orbital and this one. So let's try to get these like that. So those are overlapping. And then we're going to have this one overlapping with this one right here. And so we have a pi bond here and a pi bond there. So these shaded ones are overlapping, and then the ones up and down are overlapping. So if you look at it, I have 1, 2 pi bonds and a sigma bond, so that's a triple bond, and then 2 single bonds. So in this case, carbon is sp hybridized, and this carbon, since they're both the same, I'm just looking at one of them. Carbon has 1 single remember, we're just looking at this carbon, one single and one triple. So one single bond and one triple bond. And then as far as sigma and pi, we have 2 sigmas and 2 pi bonds. So that is how we form single, double, and triple bonds. So again, let me review quickly. A triple bond is made up of 2 pi bonds and a sigma bond. And so when a carbon, if I just look at this one carbon right here, it's going to have 2 sigmas and 2 pi bonds, and that is sp hybridized. And if you'll notice, it has 1, 2 electron domains. Then we have a double bond, and so when we have a double bond, if I just look at this carbon right here, we've got 1, 2, 3 sigmas and 1 pi. So that's 3 sigma and 1 pi bond, and it's sp2 hybridized with 1, 2, 3 electron domains. And then if we bring back the other one, this carbon has 1, 2, 3, 4 sigma bonds and 4 single bonds, and it's sp3, 1, 2, 3, sp3 hybridized. So the hybridization matches how many domains it has around it, electron domains it has around it. And we're going to look at one more thing when we're doing this. Let's just take a molecule and check out the hybridizations and figure out how many pi and sigma bonds there are in a single molecule. So in this case, let's draw carbon bonded to a carbon, bonded to a carbon, triple bonded to another carbon, which has got a single bond here. This will have a double bond to an oxygen, and then this one will have hydrogen, hydrogen, hydrogen. Okay, and so we're going to call this carbon 1, 2, 3, and 4. So carbon 1, it's got 1, 2, 3, 4 domains around it, so it's sp3 hybridized. It has 1, 2, 3, 4 single bonds, and it's got 1, 2, 3, 4 sigma bonds. Okay, so now let's look at carbon 2. Now carbon 2 has got 1, 2, 3 domains around it, and so that'll be sp2. Think about it, 1, 2, 3. So it's sp2 hybridized. And with it being sp2 hybridized, it's going to have 1, 2 single bonds and a double bond. So 2 single and 1 double. And as far as sigma and pi goes, we got 1, 2, and 3, because one of those is a sigma, so that's 3 sigmas. So 3 sigma and 1 pi from the double bond. Okay? And then since carbon 3 and carbon 4 are the same, we're just going to look at carbon 3. Now carbon 3 has got 1, 2 domains, right? This one also has, carbon 4 has 2 domains. So it's going to be sp hybridized. And in this case, so sp hybridized, sp2, and it has 1 single bond and 1 triple bond. And to make that single and triple, we've got 1, 2 sigma bonds and 1, 2 pi bonds. And so that's how we look at each one of these. Also, if I wanted to go even further, we can say that this oxygen is sp3 hybridized also because it's got 2 1, 2, 3 bonding domains, or 3 electron domains. Sorry, 3 electron domains. But right now, let's just stick with the carbons. So that is the valence bond theory and, or no, I'm sorry. Yeah, sigma and pi bonds, not the valence bond theory, but how sigma and pi bonds are used to make single, double, and triple bonds. And so that's sigma and pi bonds. And we'll see you next time.